Welcome to the 67th lecture of Digital Electronics. In this lecture, we will deal about some applications of multiplexers. And one application which needs to be dealt in detail is logic function generation. That logic function generation we will deal in detail in the next lecture. So coming into this lecture. Applications of multiplexers of MUX or multiplexers. The first and foremost application of multiplexer is data selection. So what is basically data selection? If you have n number of data, D0, D1, etc., Dn, then based on the function of a selector switch, that corresponding data, this is a selector switch, and the corresponding data is taken as output Z. Now, what is the importance of data selection? So, whichever is the correct data. For example, if you are changing the channels of your TV, the data from that particular channel needs to be routed, and you should get on the screen. So what is that application? That is on MUX. For example, if you are toggling between Asianet, Zodiac or Star Movies, etc., you need to say D0 is Asianet, and D1 is Zodiac TV, and DN is Mathrubhumi News. So what you are doing is select a switch. So you are selecting that particular channel, and data coming from that corresponding channel is already being routed to the screen. So that is an example of this MUX. Another example, if you are having a fan circuit, in the regulator you are regulating the speed. So you are selecting the corresponding speed, and only the corresponding speed is going into the fan. So that is an example of data selector. And if you are giving it into industries, if you are giving the same thing to industries, what happens is that the many processes will be working. So from each process, data needs to be routed to the next process. That means process handling. Process handling in an industry. Process handling in an industry is one of the important applications of this MUX. Second one is data routing. I think you have understood the data routing also. Data routing means you need to select a particular data from a particular point and route it to some other point. So that is known as data routing. Routing means finding the particular route. For example, I need to pass this data D0 from say point number 1 to some point. So here what you can have a selector. That selector will select the corresponding data, and another selector, so selector 2 will select the data out from here, and you can transfer to the next point. So a classical example of this data routing is if you are calling a landline. How that is being connected. The input line will be coming. That at each exchange or at each point or each node point, the data depending on the code which is generated, the connection is being done. So the time required to establish the connection, that is where we are hearing that tone. That is an example of this data routing. Now third example is operation sequencing. Operation sequencing. So what is meant by operation sequencing? Operation sequencing means, I think it is the same as this data routing. Only now in sequencing means, for example, you are having two types of multiplexing. One is time division multiplexing and frequency division multiplexing. Frequency division multiplexing. That are the two classical examples of these multiplexers. Now, in time division multiplexing, what happens is that data 1 should pass for 10 seconds. For the next 10 seconds, data 2 should be passing to the same channel. So next 10 seconds. Okay, so that sequence of operation can be done with the help of this selection. Okay, so that is an example of this operation sequencing. In frequency division multiplexing, so many data has to be transferred in parallel paths. Okay, so for that, what we have is parallel to serial conversion. 1 second. That is it. Wait for 1 minute. Yeah. So what I have mentioned is about application of multiplexers. We have dealt with data selection. Is already dealt with. Second one is data routing. That is already dealt with. Data routing. Third one, what is that is operation sequencing. That is also being explained. Operation sequencing. Then fourth one is parallel to serial conversion. So what is the parallel to serial conversion? So many data are coming in parallel. Say D0, D1, D2, etc. up to Dn are coming in parallel. Okay, and you can make it into a serial combination, like using a selector switch. You can select the corresponding data, and each data can be transferred in serial. For example, initially D0 has to be transmitted, then D1 has to be transmitted. That routing or that conversion can be done with the help of this selector switch. Okay, I think you got the point. D0 can be transferred first, then D1 can be transferred. That means the data are coming in a parallel way. Okay, this parallel data can be routed into a serial format. Okay, so that is basically parallel to serial conversion. Okay, and in module 4 we need to study about this parallel to serial conversion or parallel input and serial output. Then there also I will explain the relationship with MUX. Okay, but only difference is that MUX is basically a combination circuit, whereas if you need to get parallel in and serial out, you need to have this combination and you need to have sequential circuits. Okay, so sequential circuits is not being started till now. That we'll deal with shortly. Now the last and most important now the last one and the most important application of MUX is logic function generation. Okay, so you can use a MUX to generate any types of logic function. Logic function means this Boolean expression. Okay, for example, if you have a function like say f is equal to sigma m 1 2 3 4, this function can be generated using a MUX. Okay, sigma n means you already know that it's in a sum of products form. Okay, this can be generated using this MUX. Okay, so this part we need to deal in detail. Okay, that we will do in the next lecture. And the last application is waveform generation. Waveform generation is a critical application of this MUX. So what is waveform generation? Depending on whatever is the data, and the selector switch, the corresponding output will be selected, and it can be plotted as a wave. Okay, so that is a example of this waveform generation. Okay, so the 6 applications of this MUX are data selection, data routing, operation sequencing, parallel to serial conversion, and the most important one is logic function generation, and last one is waveform generation. So So thank you to listen to this lecture. And in the last lecture, we'll have in detail of logic function generator using maths. Thank you.